What's the answer for A?
So 606.
Huh?
Six.
So 156.
Sorry. Yeah,
156.
yeah. Sorry.
156, sir,
Sorry, 156.
What about B?
Minus 28.
Minus 28, yeah.
One's complement.
Minus 99.
Minus 100.
Next.
One 1 1 0 1 0 0 1 0.
No, no. You have to specify the decimal number.
So 210.
Let somebody else get it verified.
232, sir.
Yeah,
So 232, 232.
I am also getting that.
Yeah.
Normal VCD.
It's 156 only, sir.
No.
Oh, yes, no, sir, no.
Okay, leave that normal VCD. Go for that excessive VCD. What about this excessive VCD?
So 69.
Yes, sir, 69.
69. Now what about normal BCD?
It cannot be done, sir.
Yeah.
Invalid.
You have to specify that the pattern is invalid. That's all. Okay. Anybody is having any doubt at any part of this question? In that case, I'll explain that.
No, sir.
Follow. Okay, I assume that nobody is having any problem. Fine, thank you. Next, what I'll be starting is BCD addition. By BCD, what type of BCD I am referring to?
8421
Normal.
BCD.
Normal BCD or 8421 BCD. If nothing else is specified, by default, that the BCD has got to be the normal BCD or 8421 BCD. Fine. So my requirement is to find out the addition of using BCD format. Using BCD format, we are going for some addition. That means the decimal numbers are encoded into BCD. That means some binary flavor for the decimal number is available. And with those binary flavors, we have to go for the addition. So as the pattern is binary, may not be the binary converted version. It is the binary encoded version. So as the pattern is binary, whenever we are going for the addition operation, that addition is going to be binary addition. There is no other way I can go add two binary numbers. But my intention is to realize ultimately the decimal addition result from the binary addition. I think it is not very clear. I repeat, I have two decimal numbers. I am not going for the binary conversion. What I am going to take for these decimal numbers is encode them into binary. That means arrive their BCD versions. Now, as those BCDs are nothing but a pattern of ones and zeros, a series of ones and zeros. So if you go for addition of two series of ones and zeros, so basically that addition has got to be performed in the binary domain only. 0 plus 1 will be 1, 1 plus 0 will be 1, 0 plus 0 will be 0, 1 plus 1 will be 1, 0. So that's the only binary addition rule that we have learned. But our intention is to realize the final result to be 3, then 6, then 7, then
17.
yeah. So ultimately, what we should have is we should have from the addition, we should have the result of 17763 in BCD format. So that means what we need to do is first we have to convert this first operand into BCD. That means 1 0 0 0, then 0 0 1 0, 1 0 0, and 0 1 0 0. Second operand is 1 0 0 1, 0 1 0 0, then 0 triple 1, then 1 0 0 1. Now after going for this addition, the final result should be this should be the final requirement. This is the requirement. But definitely after adding these two patterns, I am not able to arrive at this. Are we?
No, sir.
So there must be some trick somewhere. So that rule, please note it down. The rule for the BCD addition. Obtain the BCD of both the operands. Add them using binary addition rule. Obtain the BCD of both the operands. দুটো operandary BCD obtain করলাম. And after that, we have to add them using normal binary addition rule. Now, during the addition process, if any carry gets generated during the addition process, if any carry gets generated from one nibble to next higher nibble, nibble means what do
Set
you
of
mean by
4
nibble?
bits.
Yeah, 4
Set.
bits taken at a time is called a nibble. Now, each BCD is nothing but one nibble, isn't it?
Yes, sir.
So, in case there is any carry generated from this nibble position to this nibble position, or this nibble position to this nibble position, or this to this, or this to next, in that case, you have to specially mark it. I repeat. During addition process, if any carry gets generated from one nibble to next higher nibble, specially mark it. You have to give a special marking for that particular carry. Definitely during addition, there might be one carry generated from this position to this position. But I want to mark that specially. For me, that particular carry is special, which gets generated from one nibble to and is carried to the next higher nibble. So during addition process, whenever any carry gets generated from one nibble and goes to the next higher nibble, we have to specially mark it. Okay, that's the second step. Third step. Now check the result. Now check the result nibble by nibble. That means one nibble at a time. I'll be checking. I'll be checking the result one nibble at a time, starting from least significant nibble. Starting from the least significant nibble, we'll be checking the result nibble by nibble. Now, for which purpose we'll be checking it, or what shall I go for? What check shall I make there? We have to find out whether any nibble is greater than 9. Is greater than 9 or not. So we have to check while checking one nibble, one particular nibble of a result. We'll be checking whether that particular nibble is greater than 1001 or not. This is one check. The second check is you have to check whether there was any carry generated from this nibble to next higher nibble during any previous addition operation. I am giving emphasis on the term previous addition operation. So far, while you are checking the least significant nibble, you have only one previous addition operation, isn't it? We have obtained the BCD of both the operands. Then we have gone for the binary addition. Then we started. Then we during the addition process, whenever one carry was generated from one nibble to next nibble, we made one special marking there. Now we are going for the checking the answer, checking the final result. Now that final result will be checked nibble by nibble starting from the least significant nibble. So when we are going for checking the least significant nibble, how many number of addition operations you have performed previously? When you are checking least significant nibble, how many?
Four.
Four. Why four, Baba?
Zero, sir, zero.
Zero. No addition.
Without any addition, how can you get the result?
1, sir.
Yeah. You have performed one addition, na? You have obtained both the BCD of both the operands, then you perform the binary addition. So you already have done the addition operation. And while performing the addition, you have already marked certain carries specially. And which carries were specially marked? Which carries were specially marked?
From one nibble to another nibble.
From where carry is generated.
Lower to higher.
Were going from one
Lower
particular
nibble to higher
nibble
nibble.
and was going to the next higher nibble. So that means if there is a carry here, that will be specially marked. If there is a carry here, that will be specially marked. If there is a carry here, that will be specially marked. If there is a carry from here, that will be specially marked. Okay, not these carries. Okay.
Could you please repeat the last step of the process once?
Last step means which one?
Second check, sir.
Second check, sir.
Yeah,
Carry
second check,
generated
I'll
from previous
come to that. I'll come to that. So while now you have started checking the least significant, checking the result nibble by nibble, starting from the least significant nibble. Now, while checking the least significant nibble, how many previous addition operations you have performed?
One.
Okay, fine. Now the second check is the first check is we have to check whether the nibble we are checking it is more than 1001 or not. Or the second check that we have to perform is whether there was any carry generated from this nibble position to the next higher nibble position during any previous addition operation. That means when you are checking one particular nibble, prior to that, whatever addition operations you have performed, during those addition operations, if there was any carry from this particular nibble to the next higher nibble, you have to find out whether there was any such carry or not. Now you got the second check, or should I repeat?
Sir, please repeat once more.
Yeah. I'll start it from the very beginning once again. Obtain the BCD of both the operands, add them using binary addition scheme or using the binary addition rule. During addition, if any carry gets generated from one nibble and goes to the next higher nibble, we have to specially mark it. Now the result is obtained. Here we have to check the result nibble by nibble starting from the least significant nibble. While checking a nibble, we have to make two checks. We have to find out whether the nibble value is more than 9 or not. That means whether the nibble value is greater than 1001 or not. Second check that has to be performed is whether any carry was generated from this nibble to next higher nibble during any previous addition operation. How will you find whether that carry was generated or not?
Shall we have made a
We have
mark?
marked it.
From the special markings. So that's why those special markings are necessary. So when I'm checking for this particular nibble, so I'll first check whether this nibble value is greater than this or not. Second check is whether there is a carry from this nibble position to this nibble position or not. Now, if either of these two cases arise, if either of these two cases are satisfied, so either the value is greater than 9 or there was a carry from this nibble to next higher nibble, এই দুটোর মধ্যে যে কোনো একটা যদি হয়, in that case we have to make one corrective action. And what is the corrective action? Now we have to add 6, that means 0, 1, 1, 0 with this nibble position. I repeat. If any of these two is found to be true, that means either one carry was generated from this nibble to next higher nibble, from that special marking I can find it out, or the value of this particular nibble is greater than 1001. এই দুটোর মধ্যে যে কোনো একটা কেস যদি arise হয়, what I'll deduce is, I'll infer is that the result obtained is not the correct result. I have to make one corrective action. And what is the corrective action? Now I have to add 6, that means 0, 1, 1, 0 with this nibble position. Now continue this till all the nibbles are checked and corrected. Continue this process till all the nibbles are checked and corrected. Let us do it for this particular specific example only.
So we have to add that with the least significant nibble of the result.
Let us go for this example. That will make the thing pretty clear. Okay. So this is your 1, 0, 0, 0. After addition, what will be the result? Okay. Any doubt?
No, sir.
No, sir.
So there is a carry from this nibble to next higher nibble. So I have specially marked it. Okay. Have you seen that special marking?
Yes, sir.
Fine. Now, what is the next task?
Look from least
Check
significant
We have
nibble.
to
The
fix
least
the result
significant
nibble by nibble starting from the least significant nibble. So first, we shall target this particular nibble.
greater than nibble.
This particular nibble. Is it greater than 9?
Yes, sir.
Yes, sir.
Yes, sir.
So what you have to do? You have to make some corrective action. What is that corrective
Yeah.
action?
Add 6 with
Yes.
0.
Add 6, 0, 1, 1, 0.
Okay. Now, one thing you must remember that we'll check one nibble only once. Once the one corrective action is taken, we should not go for rechecking that particular nibble. Okay. So during this addition operation, this is the second addition operation. This was the first addition operation. This one. This is the second addition operation. Now, during the second addition operation, there was a carry from the least significant nibble to next higher nibble, then from this nibble to next higher nibble. So, as per our convention or the rule, we have made special markings. But this particular special marking was done while checking that particular, that specific nibble only. Is it not? This
Yes, sir.
particular special marking was made when we were taking the corrective action for this particular nibble. But once the corrective action is taken, no further action will be allowed with that nibble. So, though as per our convention of the rule, we have made this special marking, but this will be of no use in this particular least even nibble case. Now let me go to the next higher nibble. What is the value of the next higher nibble? What is the value of the next higher nibble? 0.
0, sir.
Is it greater than 9?
No.
No. Then
Carry.
what is the next check?
Check for carry.
Yeah. Was there a carry generated from this nibble to next higher nibble during any
Yes,
previous
sir.
addition operation?
Yes, sir.
Yes, sir.
Where? No, here. Okay. So what I have to do?
Add 6.
Add 6 to the current nibble.
Uh-huh.
Now go to the next higher nibble. Two nibbles I have checked and made the correct reactions. Now we go to the next higher nibble. What is the value? Is it more than 9?
No, sir. 7.
Was there any carry from this nibble to next higher nibble during any? How many previous addition operations are there, by the way?
3.
3. Was there any carry generated from this nibble to next higher nibble during any previous addition operation?
No, sir.
No. So do you need to make any take any corrective action?
No, sir.
No, sir.
So that nibble is already okay. Now go to the next higher nibble. Is it more than 9?
No, sir.
No, sir.
No, sir.
Was any carry
No,
from
sir.
this nibble to next higher nibble?
Yes, sir.
Yes, sir.
So I
Yes,
have to
sir.
add 6. Okay. So the 4 nibbles are now okay. Now you are with the final nibble. So here I have only 1. So that means I have 3 leading zeros. Okay. Now is this nibble greater than 9?
No, sir.
No, sir.
Was any carry from this nibble to next higher nibble?
No, sir.
No.
No, sir.
So this is the final result. So what is this
Yes.
final result? Now 1, 7, 7, 6, 6. Is the process clear to everybody? Or should I
Yes, sir.
repeat?
Yes, sir.
Yes, sir. It's clear now.
Let me take one more example.
Sir, can you show the last slide again one more
Yes,
time,
yes.
sir? Sir.
Should I proceed?
Yes, sir.
Right. Whatever. You start doing it yourself and then I'll do.
Yes, sir.
Is my answer correct?
Yes, sir.
Yes, sir.
Fine.
So, but in the last step, there is the from 1100 to 0100. There is one carry, but we are
Yeah.
not considering that. Why?
That's we discussed here, na? When, by the way, when that particular carry was generated?
In the last part one step,
When was this carry generated?
during adding 6.
During taking the corrective measure for that particular nibble.
Yes, sir.
How many times you can check one nibble?
One time only.
Only one. So, though that carry was generated from this nibble to next hand nibble, but this carry was generated while taking the corrective action for this nibble only. So, there is no scope for considering that particular carry specially.
Okay, sir.
Isn't it?
Yes, sir.
আগে এই কেসে যেখানে বললাম এই যেখানটা
And sir, we have to correct the which level from where the arrow is going or to where the arrow is going.
No. কি বলেছি? What you are checking while checking one nibble, what you have to check whether that nibble value is greater than 9 or not. Second thing is whether there is any carry generated from this nibble to next nibble or not. এই দুটোর মধ্যে যে কোনো একটা হলে তবেই সেই নিবিলে কারেক্টিভ অ্যাকশন নেব।
স্যার আমি সেকেন্ড কেসটা কথাটা বলছি, মানে যেখান থেকে নেক্সট নিবিলে যেটা ক্যারিটা গেছে ওই ফার্স্ট
No. You just go back to the rule. What the rule says, under which condition you are taking the corrective measure. You are taking corrective measure for which nibble? The nibble you are checking for. You are checking the result nibble by nibble. So one nibble at a time you are checking, isn't it? So
Yes, sir.
now in this case you are checking this particular nibble, isn't it?
Yes, sir.
So now while checking that nibble, what do you find? You find that there the value of that nibble is greater than 9, 1001. So you have straight away gone for taking the corrective measure.
Yes, sir.
So while taking that corrective measure, this particular carry was generated. So will it have any further effect on this particular nibble itself?
No, sir.
Because I have already taken the corrective measure. Okay.
Yes, sir.
Okay. Thank you. So any doubt regarding the process from anybody?
No, sir.
No, sir.
There should have been. There should have been one straightforward question coming
Why
from you.
6 is added, sir?
Yeah, that's it. Why is this process?
To wrap around. So to wrap around.
Why is this process?
Sir, 4-bit
Why is
16.
it, going for
Yes, sir.
checking nibble by nibble, and then we are taking some corrective measure under two conditions. If the nibble value is greater than 9, or if one carry was generated from this nibble to next hand nibble. And that too, the corrective measure is by adding 6. Why is this? That should have been the question or the query.
Sir, greater than 9. So when we add 6 to it,
Let me explain it first, then
yes,
I
sir,
will
yes,
take
sir,
it.
yes, sir.
Say, I have two decimal numbers A and B.
Sir, your presentation has stopped.
Oh, stop, na?
Yes, sir.
Please, once again, you have to give me some 2 minutes time.
No problem.
I have to restart my laptop. Yeah, every day that happens. But the one thing, during the process, what is our main intention?
Addition.
Addition of what?
Addition of BCD.
Decimals.
Normal BCD.
Addition of two decimal numbers. So that means our intention is to go for decimal addition, but via binary process. Is it not?
Yes,
Yes,
sir.
Well,
Yes, sir.
my input is decimal number. My output I am expecting to be the decimal number. Decimal number, but not exactly in decimal number. They are in BCD pattern. But when those BCD patterns are added, that addition has been made in the binary process, binary addition scheme, using the binary addition scheme or using the binary addition process. But the result that I am expecting is that from one, that what is realizable for the decimal addition. So I want to achieve decimal addition via binary addition scheme. This point you please keep it in your mind. This will help you in understanding this why that 6.
Hello.
Yeah,
Acha, sir, you weren't audible, I think.
no, I'm just
Acha, acha, acha.
restarting.
That's fine. I thought my internet got.
My laptop is pretty old, almost 13-14 years back we purchased it, but still I am using it because it has got a touch screen. So that's for that only reason only I am using it.
Yeah, sir.
So 14 years ago, touchscreen laptops were not available, sir.
No, actually, some 14, 15 years back, we were having some project with ISRO. So from that project, we purchased two industrial grade laptops from Panasonic. So at that time, it was around 1,86,000 rupees per piece. And as it is industrial grade, if you even drop it from 3 feet height, it won't be, there will be no damage. So it is still working. Say, I have two decimal numbers A and B. Basically, my then intention is to go for the BCD addition of for the ith position. My intention is to go for the BCD addition of AI and BI. Now, what is the maximum possible value of AI? Decimal in decimal?
9, sir.
9. What about the BI?
9.
Only.
If you add these two, what can be the result?
18.
18. Fine. This is one point we shall keep it in your mind. Now, when you are adding two decimal digits, under which condition one carry gets generated?
Greater than 9.
Whenever, if I am mark it as the result I, whenever your Ri is greater than 9, carry should be generated, isn't it?
Yes, sir.
Now, we're not, are you actually doing the decimal addition here? Is the process the decimal addition process?
Yes, sir.
No, the process
BCD.
actually involved is the binary addition process, isn't it? Our
Yes.
requirement is to get the decimal addition result, but via binary addition process. Now, during the binary addition, I am not converting A and B to binary. What I have done is I have obtained the BCD patterns of A and B. Now, for AI, I have one 4-bit BCD pattern, and for BI, I have one 4-bit BCD pattern. Though in the decimal domain, this is a single digit addition, but in binary domain, it will be
4 bits, sir.
4-bit addition. So if I mark those bits to be A3I, A2I, A1I, and A0I, and BI is B3I, B2I, B1I, and B0I, then basically we're instead of AI plus BI, we're basically adding these 4 binary bits. But each of those 4 binary bits represent the BCD, normal BCD pattern of AI and BI respectively. Clear?
Yes, sir.
Fine. Now tell me under which condition one carry will be generated from a 4-bit binary addition? When will the carry be generated? When you are going for two 4-bit binary patterns or two 4-bit binary numbers?
Sir, if A3I
Number greater than 8.
Greater than 15.
Greater
Greater
than?
than 8.
8.
No. Anita?
So greater than 15.
15.
Greater than 15. What is the maximum possible value that can be accumulated within this 4-bit pattern? There's 15 only,
15.
Na? All one.
Yes, sir.
So when the result, expected result exceeds this 15, then one carry gets generated. Now, when you are here say I have a 2-digit decimal number A1, A0. So with that I am adding B1, B0. So when I am adding A0 with B0, if a carry gets, if the result becomes more than 9, one carry should be generated and that should go to the next higher stage. Clear? When I am adding A1, A0 with B1, B0, remember this A1, A0, B1, B0 are all decimal digits. That means I am assuming A to be a 2-digit decimal number and B to be also one 2-digit decimal number. Okay. So when you are adding A0 with B0, if the summation result exceeds 9, one carry should get generated and that should go to the next higher stage. Is it not?
Yes, sir.
Fine.
Yes, sir.
Now we are not doing the decimal addition at all here. What we are doing? We are finding out the BCD pattern of A1. We are finding out the BCD pattern of A0. So those 4 bits and those 4 bits are written side by side. Similarly, BCD pattern of B1, BCD pattern of B0. We are adding them. But this addition is no longer decimal addition. This addition is binary addition. Now, when I am adding, definitely I'll be adding this nibble with this nibble position. So after addition, one carry will be generated from this nibble to next higher nibble under which condition?
If the result is greater than
If
15.
the result is greater than 15. So till the result is up 15, there will be no carry generated. So though my A0 value is 8 and B0 value is 7, the result that I am getting here is all 1. But the result that is expected here is 5 and then 1 as carry, isn't it?
Yes, sir.
So what have to do? There is a discrepancy in during after how much result there is a carry generated from one nibble to next higher nibble. During decimal addition, the carry gets generated whenever the result is greater than 9, whereas during binary addition, the carry gets generated whenever the result is more than 15. So what we have to do is, after obtaining this binary addition, we have to check this result. If this result is 9, that means we know that in decimal domain, one carry was required to be generated. Is it not? If the binary
Yes, sir.
addition result is greater than 9, we know that as the result is greater than 9, if I had gone for the actual decimal addition operation, one carry was already available with me. But here I am not getting the carry. It has to wait till 15 and then it will generate the carry. So what I will do is, what is the difference between this 9 and 15?
6.
So whenever you find that the result is more than 9, you force it to become more than 15 by the same amount. If the result is 12, that means by how much it is greater than 9?
3.
3. So add it with 6. So how much that result becomes?
18.
18. So
Six
how
greater
much
than
that is
15.
more than 15?
3.
3. So same bias, same difference I'll be getting. So whenever the result exceeds 9, you have to make it more than 15. That's all. So to achieve that, you have to give one steady bias of 6. But that was the case when the result was supposed to be greater than 9. Why, when the carry was generated, then also you are giving the same bias? This answer I do expect from some of you.
Sir, repeat the question.
Here we have already how many checks we are doing for one nibble, whether that nibble value is greater than 9, or whether there is a carry from this nibble to next higher nibble during any previous addition operation. If any of these two cases are there, in that case I was giving one bias of 6. So already it is explained that if the result is more than 9, I should give the bias of 6. So that I think all of you have understood, is it not?
Yes, sir.
Yes.
Yes, sir.
My second question is, in that case, why we are giving the same bias of 6 when one carry is found to be generated from this nibble to next higher nibble during any previous addition operation?
Carry is there, then that means there was, that is more than.
That's it.
So the number is more than 15.
Yeah.
So
Carry is generated, that means the number is already more than 15. That means the number is already more than 9 itself.
yeah, we have to have 6.
So I have to give that bias of 6. That's it. So hope why is this process that is clear? Is anybody having still any doubt?
No, sir.
Fine, thank you.
No, sir.
So the BCD addition rule is a bit complicated. We have to go for 2 different types of checkings. Whether we have to find out whether the nibble is greater than 9 or not. Then we have to find out whether one carry was generated from this nibble to next higher nibble or not. So these 2 types of checkings are to be performed for each nibble. Now in the case of excessive BCD, rule is a bit simpler. Here we have to check only one thing, that is whether during any previous addition operation one carry was generated from this particular nibble to next higher nibble or not. The process remains the same. First obtain the excessive BCD of both the operands, add them using binary addition rule. So up to this there is no difference. And another thing is also there, during any addition operation, if any carries gets generated from one nibble to next higher nibble, we have to specially mark it. That is also the same as the BCD addition rule. Now the difference comes. After going for the first addition, we have to start checking the result nibble by nibble starting from the least significant nibble. And while checking any particular nibble, what you have to do is you have to check whether any carry was generated from this particular nibble to next higher nibble during any previous addition operation or not. Nothing else needs to be checked. Whether the result is greater than 9, something, that thing is not there here. Only একটাই point, whether from this particular nibble position, sorry, or whether from this particular nibble position one carry was generated or not. Only that particular checking is there. Now, if a carry is found to be generated, what we'll be doing is we'll be adding 3 with it. Earlier, you were adding 6 with the result, but here,
Sir,
follow.
sir, up to step 3, everything is same, but from step 4, the things get changed. So can you please repeat step 4?
step 3 টা কোনটা ছিল বাবা, আমি ভুলে গেলাম। আমি তো গড়গড়কে বলে আছি step 1 step, what is that step?
Mark when there is a carry.
What is the step 3?
Means we have to specially mark the carry.
Fine. That, up to specially marking is everything was good. Now you have to check the result nibble by nibble starting from the least significant nibble. While checking any nibble, we have to find whether any carry was generated from this nibble to next higher nibble or not. Whether any carry was generated from this nibble to next higher nibble during any previous addition operation or not. আমি যখন একটা নিবলকে চেক করছি during any previous addition operation from this nibble to next higher nibble, whether there is any carry generated or not, that's the only point I have to check. if a carry was found to be generated, you have to add 0, 0, 1, 1. That means 3 with this nibble position. Otherwise means if no carry was generated from this nibble to next nibble during any previous addition operation, in that otherwise case, we have to subtract 3 from this nibble position. So either we'll be adding 3 or we'll be subtracting 3. Either we'll be adding 0, 0, 1, 1 or we'll be subtracting 0, 0, 1, 1, depending upon whether a carry was generated from this nibble to next nibble or not. So যদি carry থাকে, we'll be adding 3, carry না থাকলে we'll be subtracting 3. Okay, now let us go for the same example. What is the last example that is done for? 786 2479. We have to add these two. This 786, that means here I have a 0. Is it not? So now we have to find out the excessive BCD of both the operands. So what will be the first excessive BCD? You dictate me.
0, 0, 1, 1.
0, 0, 0, 1, 1.
1, 1, then 1, 1, 0, 0. Then this is 8 plus 3 is 11. That means 1, 0, 1, 1. 6 means 9. 1, 0, 0, 1. Hopefully ঠিক লিখেছি। No, 7টা ভুল লিখেছি। 7টা ভুল লিখেছি।
1, 0, 1,
1, 0, 1, 0.
10 হবে। 2 is 5. 4 is how much? 7. 7 is how much? 10 once again. 9 is 12. ওকে, দেখে নেবে না ভুল, এই স্টেপে ভুল হলে তুমি পুরোটাই ভুলে যাবে। ভেরিফাই করে নিও, ঠিক হলে বলো, তারপর প্রসিড করবো।
Yes, sir.
Fine. Now I have to check the result nibble by nibble starting from the least given nibble. So when I am checking this particular nibble, was any carry generated from this nibble to next hand nibble?
Yes, sir.
Yes, sir.
So what I have to do, I have to add 3. Next, was any carry from this nibble to next hand nibble?
Yes, sir.
Yes, sir.
Fine. Then for this third one also, there was a carry from this nibble to next hand nibble. final the most significant nibble. Was there any carry from this nibble to next higher nibble?
No, sir.
No, sir.
You have to subtract 3. So this is the result. Remember, this result is available in XS3 BCD. So what should be the what is the actual result? This 6 means how much?
3.
3.
2, then 6,
6.
then 5.
5.
So देखिए था 5, 6. Huh. Okay. Now let me go for one subtraction operation in BCD. Now the subtraction operation definitely we should try to use the subtraction in using the by means of the addition scheme. That means either we have to go for the 9's complement or the 10's complement number system version. So here this 962 is the positive number, and 264 I am going to subtract it from this 962. That is basically what we are going for is this operation. So if we are going for the BCD patterns, normal BCD patterns, then we have to go for the normal BCD of 9, then 6, then minus 264. So let me go for the 9's complement scheme. So what is the 2's complement minus 264? What is the 9's complement of minus 264? What is the 2's complement of minus 264? Sorry, once again I'm doing the same mistake. What is the 9's complement of minus 264? How do you get the 9's complement?
735.
Yeah, you have to subtract each digit from 9.
999.
So 735, 735. So what is the BCD for that? Add them using binary addition scheme. There is one end around carry. Is it not?
Yes, sir.
So what you have to do with the end around carry in that R minus 1's complement addition?
Add to the LSB.
LSB addition.
Okay, so that's the result. Now I have to go for checking the result nibble by nibble, starting from the least significant nibble. Remember, here you have gone for the decimal BCD addition, not the XS3 BCD addition. So you have to check. You have to go for 2 checks: whether the nibble is greater than 9 or whether there is a carry from this nibble to next nibble or not. Is this nibble greater than 9?
No, sir.
No, sir.
Was any carry from this nibble to next higher nibble?
No, sir.
No, sir.
Fine. So there is no corrective action measure should be there. Second nibble. Greater than 9?
No, sir.
No, sir.
Carry?
No, sir.
No, sir.
So no more corrective action. So first two nibbles are already okay. Finally, the last nibble. Is greater than 9?
No,
No,
sir.
sir.
Was any carry from this nibble to next higher nibble?
Yes, sir.
So you have to add 6. So what is the result? 6, 9, 8. Okay. Let us try to do the same subtraction using excessive binary. In excessive
স্যার
binary,
এখানে স্যার এখানে রেজাল্টটা যদি মাইনাস আসতো তাহলে কি হতো?
বা আমি সেটা একটু কমপ্লিকেটেড কেস, আমি সেখানে যাচ্ছি না এখন।
ওকে স্যার।
If I now go via the excessive BCD, so we have to find out the excessive BCD of both the operands. So let me go for 9. What was that? 962 minus 264. So excessive BCD of 962. What is that? 110012. Then 9 1001. 2 means 5.
010.
আচ্ছা, এইবার আমাকে বলো তো এই নেগেটিভ নাম্বারটা -264 তার 9th কমপ্লিমেন্টের এক্সেসিভ বিসিডি কত হবে? সো ফার্স্ট টেল মি হোয়াট ইজ দ্য 9th কমপ্লিমেন্ট -264. That's already we have 735. So we have to find out the excessive BCD of 735. So 7 means your 7 plus
1010.
101.
0110.
5 means 8.
1000.
Okay, fine. Then 1011 1111 0110. The carry. Okay, so that carry needs to be added to the least significant position. So that is now 0 1 1 1, then 1 1 1 1 0 1 1 0. Now I have to check the result nibble by nibble starting from the least significant nibble. So when we are checking the least significant nibble, was any carry from this nibble position to next higher nibble position?
No.
No, sir.
So কি করতে হবে?
Add 3.
No.
Subtract 3.
Subtract 3.
No, subtract 3, sir.
1, then this will be 1 0 1. Fine. Next fellow is the same thing. I have to subtract 3. From this nibble to next higher nibble, was any carry?
Yes, sir.
So I have to add. Okay, so this is the final result. Remember, the result is available in excessive BCD format. So what is the decimal pattern? Decimal number?
6.
This is 6. Then
9
9.
8
698.
98.
Okay. So আমার একটা জিনিস দেখতে পাচ্ছি কি, if we have to go for the subtraction operation, then normally we will prefer subtraction operation using the addition scheme. Now, if we have to go for the BCD subtraction, so there also we have to take help of the 9's complement addition or 10's complement addition. Now here we have given some two examples of the 9's complement addition, one for the normal BCD, the other for the excessive BCD. But in both the cases, given the negative number, we have to find out its BCD or the excessive BCD. Now operands, when you are asked to go for A minus B, the value of A is 962 and the value of B is 264. So when the data is given as input to the computational system, then the BCD pattern of A and the BCD pattern of B are given to you. That means you are supplied with 1 1 0 0 1 0 0 1 0 1 0 1 and 2 is your 0 0 1 0, 6 is and 4 is, that's sorry এটা ভুল লিখলাম আমি একটা লিখলাম এক্সেসিভ বিসিডি, একটা লিখলাম আমি নরমাল বিসিডি, তাই তো? হ্যাঁ, this is in excessive BCD. The above one is the excessive BCD and the below one I have gone for the normal BCD. That's totally wrong. If you are going for the excessive BCD, in that case the excessive BCD of 962, that is given as the input, and the excessive BCD of 264, that should be given as the other input. So what is the excessive BCD of 264? No, 0, sorry. Two, then 6, then 4. 4 means 7. So these are the two inputs. And if you go for the normal BCD addition, that means if you go for the subtraction using the 9's complement with the normal BCD numbers, in that case the inputs are 1 0 0 1, 0 1 1 0, 0 0 1 0, and then B is 2, that means 2, 6 is, 4 is. So these are the two inputs. This is one input, this is the other input. Whereas here, yeah, and if you go for the 9's complement scheme, sorry, excessive BCD scheme, this is one input and this is the other input. But as the subtraction is being implemented using the 9's complement scheme, addition scheme, for the negative number, we have to find out the corresponding 9's complement, and then only we can go for the addition, isn't it? As we are going to implement the subtraction operation using the 9's complement addition scheme, so whatever negative number is there, that needs to be first converted into its 9's complement. So given this pattern, this is a negative number pattern. In which system? Normal BCD or excessive BCD? Excessive BCD. So from here, I have to convert it by some means and come to this particular pattern. Then only I can go for the addition. This is the negative. This is the excessive BCD format representation of this minus 264. That is the negative number. But as we are going for the 9's complement addition, we have to find out the excessive format or excessive pattern for the decimal number 735, which is the 9's complement of minus 264. So there must be some mechanism by which I can convert this pattern and arrive at here. Same is true here. Here the inputs are this pattern and this pattern. This is the positive pattern, this is the negative pattern. For this negative pattern, I have to find out its 9's complement version. That is the normal BCD pattern for 735. So that means from here, I have to straightaway, there must be some mechanism by which I can come to this particular pattern from given this pattern as the input. Given this pattern as the input, I should be able to arrive at here by some rule. Can you find out any such rule for this conversion?
So we can convert it into decimal, then find it 9's complement and back to.
We won't go for that. We won't go for that. Because once this pattern is given as input to the digital system, the digital system does not understand any decimal number. It only understands binary. See, it won't be possible for the digital system to go to the decimal, then to subtract from 9 each number, then go for its normal BCD version. That is not possible. There should be some truth table type of thing where given any particular pattern, I can find out its 9's complement. Now let me go for the other one. Here. Is there any straightforward pattern?
The inverting of the bits.
Just by simple bitwise inversion, by simply going for bitwise complementation, we can arrive at the 9's complement. That's the speciality of XSTBCD. First of all, here this for BCD addition, we are going for two checks. One is whether the nibble is greater than 9 or not, or whether there is a carry from this nibble to next nibble or not. Here I have only a single check, whether a carry is generated from this nibble to next nibble or not. If the carry is generated, add 3, otherwise subtract 3. That's one simplification. The second thing is, if you go for the subtraction process, then you can obtain the 9's complement of any excessive BCD pattern by simply going for bitwise complementation. What is the 9's complement of 0? What is the 9's complement of 0?
1, 1, 1, 1.
No. What is the 9's complement of 0 in decimal?
9999.
No. 0, single digit.
0.
9.
9. What is the 9's complement of 1? 1, basically I am talking about minus 1.
Yes, 8.
8.
7, 6, 5, 4.
7, 6, 5, 4, 3, 2, 1. From this BCD pattern 0, 0, 0, 0, there is no way you can straight away find out a 1, 0, 0, 1 pattern, isn't it? There should be some complicated rule. There is no straightforward rule. You have to go for one truth table and then find out the corresponding logic circuit. That's one complicated process. But here, the excessive BCD pattern of 0 is 0, 0, 1, 1. If you go for bitwise complementation, it becomes 1 1 0 0. That is the excessive BCD of 9. For 1, excessive BCD is 0 1 0 0. If I go for the bitwise complementation, it becomes 1 0 1 1. So that is the excessive BCD of 8. So that means you will find that every excessive BCD pattern, if I go for its bitwise complementation, will be arriving at the corresponding 9's complement, the excessive BCD pattern of the corresponding 9's complement. That's why this excessive BCD, where just by taking bitwise complementation, we arrive at the excessive BCD of the 9's complement. That's why this excessive BCD is called one type of self-complementing BCD. What do we mean by self-complementing BCD? Now, in the case of self-complementing BCD, if I go for the bitwise complementation of any BCD pattern, we arrive at the BCD pattern of the corresponding 9's complement. If any BCD conversion rule or the BCD encoding rule satisfies this criteria, that particular BCD rule will be termed as one self-complementing BCD rule. Is the normal BCD or the 8421 BCD rule comes under the self-complementing BCD?
No, sir.
No, sir.
But the excessive BCD is coming under this self-complementing BCD category. Now let me go for that 4221 BCD, which we left unfinished. For 0 and 1 and 8 and 9, there are unique patterns. But for others, for each pattern, there are two versions. Is it not? For 2, I have two possibilities. 0 0 1 0 or this yellow, they are basically or. 0 0 1 0 or 0 1 0 0. Either of these two versions I can go for 2. For 3, 0 0 1 1 or 0 1 0 1. Any of these two should be is possible. So this way I have up to 7. For 2, 3, 4, 5, 6, 7, I have two possibilities each. Now go for the 0. The pattern is 0 0 0 0. If I go for the bitwise complementation, what do we get?
1 1 1 1.
So that's the 9's complement of 0. For see that 8 and 1, they are also self-complementing. From 8 I can go to 1, and from 1 I can come to 8 by simply bitwise complementation. So they are self-complementing, and 8 and 1 are 9's complement of each other. For 2, what is the 9's complement of 2? What is the 9's complement of 2?
7 7 7.
So if I take this pattern for 2, I should take this pattern of 7 to make this pair self-complementing. Or if I take this pattern for 2, I should take this pattern for 7 to make it self-complementing. Is it clear? If I take 0 0 1 0 pattern for 2 and 1 1 0 1 pattern for 7, that pair becomes self-complementing. Just by bitwise complementation,
Yes.
I'll go from one to the other one. Similarly, instead of 0 0 1 0, if I go for 0 1 0 0 for 2, I should go for 1 0 1 1 for 7 to make that pair self-complementing again. Okay? So, এই দুটোর মধ্যে যে কোনো একটা অপশন নেই। Similarly, for 3, if I go for 0 1 0 1, what is the same 9's complement of 3?
6.
6. I should go for 1 0 1 0 pattern for 6. Whereas if I go for this pattern, I should go for this for 6 to make that pair self-complementing again. Okay. For similarly for 4, if I go for this, I'll go for this for 5. For 4, if I go for this, for 5, I'll go for this. So this way, I can make 4-2-1 BCD also one self-complementing BCD. But truly speaking, this 4-2-1 BCD has got a very few applications. So we are not that much bothered about 4-2-1 BCD, but we are and for arithmetic operations, this XST BCD has got some very good amount of applications. What's the time now?
Sir, sir,
yeah.
is there any way we can have the complement of BCD, means the standard BCD means we have talked about XS3 BCD 4-2-1.
No such a straightforward method is there. I'll tell you how can you do it.
Okay, sir.
And there is that question. I'll say. Basically, if 0000 is the BCD pattern, that means the decimal number is
0.
Zero. So what should be the ninth complement of 0?
9.
So that means my WXYZ, that should be 1001. Next, 0001. If that is the BCD pattern, what is the ninth complement?
8 1000.
Here it should be 7, is it not? 2 এর জন্য
0111.
একটু আঙ্গুল বলে দাও না, ভুল হলে বলো কিন্তু। Okay, so you have to realize one logic circuit where you have 4 input lines. They are A, B, C, D, and how many output lines?
4. X, Y, Z, W.
Okay, so that means you have to design this particular logic circuit. If you can design that particular logic circuit, you should be able to convert the BCD pattern to its 9th complement straightaway. But there is no straightforward rule. There is a complicated circuit there internally, which must satisfy this particular truth table. You remember that what do you mean by truth table? There all possible input combinations should be listed, and for each input combination of what are the required output, that should also be listed there without any ambiguity. So that truth table is already available with me now. So now once the truth table is available, how you can design the corresponding internal circuit or the corresponding logic circuit, that design process will start from the next class. Okay, so but Nirav, what was your question?
Sir, my question was how to build this logic circuit. Means how can
So
we
that is,
convert?
you have to build this the logic circuit which satisfies this truth table. But until
Yes.
unless we learn how to convert one particular truth table into a logic circuit, we won't be able to understand this. But one thing is pretty sure: there is no straightforward, just simple method whereby from this ABCD we can come to WXYZ. But had it been excessive ABCD, in that case, my 0 was 0, 0, 1, 1, and this ninth complement was 1, 1, 0, 0. So what we have found that there, just by simple bitwise complementation, I can come from one particular pattern to its corresponding ninth complement pattern. But that is not possible in normal BCD. For normal BCD, we need to design one particular complex circuit. Okay, বুঝে গেছে?
হ্যাঁ স্যার। স্যার স্যার লাস্ট স্লাইডটা একটু দেখাবেন?
কোনটা এটা?
হ্যাঁ স্যার হয়ে গেছে।
So next class আমি তোমাদেরকে যদিও আমি বলেছিলাম যে you should erase all your previous memories regarding the digital whatever things you have studied regarding digital electronics. But still এই জিনিসটা কোথাও ভুল পড়ানো হয় না, তার জন্যই বলছি ওই বুলিয়ান অ্যালজেব্রা, that a dot a is equal to a dot 0 is equal to 0, 0 plus a is equal to a, 1 plus a is equal to 1, এই যে বুলিয়ান অ্যালজেব্রা গুলো সেইগুলো একটু জাস্ট যদি যে কোনো সোর্স থেকে দেখে আসতে পারো তাহলে আমার একটু সুবিধা হয়। ওকে,
ঠিক আছে।
তো নেক্সট ক্লাসে আসার আগে জাস্ট এই বুলিয়ান অ্যালজেব্রা গুলো জিনিসটা কি ছিল একটু ভাবার চেষ্টা করে এসো।
হ্যাঁ স্যার।
ওকে, তো নেক্সট ক্লাস ইজ থার্সডে না কবে?
হ্যাঁ স্যার, থার্সডে 10 এর সময়।
আচ্ছা, প্লিজ একটা জিনিস সিয়ারদের বলছি যে একটু চেষ্টা করো 10 ও 5 এর মধ্যে যেন সবাই ঢুকে যায়, কারণ কি পরে আমি ক্লাস শুরু করার পরে ঢুকতে থাকলে না আমাকে ওই বারবার মানে অ্যাটেনশনটা চলে যায় ওদিকে।
ওকে স্যার।
ওটা একটুখানি ক্লাসে বলে দিও, সে 10টা 5-এর জায়গায় 10টা 6-7 হোক, ঠিক আছে চলবে, কিন্তু অনেকেই দেখছি আবার সে 10:30টায় ঢুকছে, ওইগুলো করা ঠিক না, একটু বলে। আচ্ছা, Mohsin Mansoor, absent. Ashish Patro, absent. Boivar Shaw, present. Yogesh Tiwari,
Present, sir.
Mustafa Kamal,
Present, sir.
Shubhlin Singh, absent. Shikha Shaha, absent. Sawaj Parvez,
Present, sir.
Suraj Mohan Soren, absent. Brotin Ghosh. Today I am going for a different process where I'll be going for the roll call. You don't have to write your roll number in the chat box. Brotin Ghosh, absent. Shandiporna Bormon, Shandiporna or Shandiporna?
Sandipurna.
স্যার সন্দীপূর্ণ।
Rion Shamanto, absent. Ankit,
Present, sir.
Saurabh Sen,
Present, sir.
Sangram Saha, Sagar Choudhury,
Yes, sir. Present, sir.
Biplab Sarkar,
Yes, sir. Present.
Moinak Das,
Present, sir.
Ayushman Brahmo,
Yes, sir. Present.
Shuddha Satto, Aniket.
Yes, sir. Sir, I am present, sir.
Yeah, Aniket.
Yes, sir. Present.
Udvash,
Present, sir.
Somojit Acharya, absent. Arnav,
Present, sir.
Nilargho, Parvez,
হ্যাঁ স্যার আছি স্যার।
Parvez,
Present, sir. Present, sir.
Ashraf Hussain,
Present, sir.
Srinjoy Mondol, Absent. Rashid Asgar. He has not yet joined my class so far. Has he left Jadavpur University? Sir, have you got any information?
No, sir.
No, sir, he has not left the university. He is there in our class.
Okay. Okay,
And
Srinjoy
sir, Srinjoy was present.
Aryan Shodhar. Absent. Anindita present. Pallab Kumar Mondol. Absent. Prosenjit Mondol.
Pallav has got some medical issues and he will not be able to join the class.
That's a different issue. Prosenjit Mondol.
Yes, sir.
Shoham Kanji.
Present, sir.
Shilpa Mondol.
Yes, sir.
Anirban Noshkar.
Present, sir.
Joydeep Maji. Shubhajit Mondol.
Present, sir.
Shubhajit Mondol.
Yes, sir.
Midul surname ki?
Sure.
Yes,
sir.
sir.
The middle soil. Yes, sir, soil.
Absent. Fine. Mrityunjay Orao. Absent. Surjo Kumar Majhi. Absent. Nishant Patel.
Present, sir.
Gulshan Poddar. Ovirup Kaviraj.
Present, sir.
Ornik Chakraborty.
Present, sir.
Shomik Chaudhary.
Present, sir.
Orijit Pai.
Present, sir.
Pai. Rajdeep
Present,
Kundu. Rajdeep
Present, sir.
Kundu.
Present, sir.
Ovirup Saha.
Present, sir.
Shaurjo Dotto.
Present, sir.
Sritoma Ghosh. Absent. Himanish Pal.
Present, sir.
Himanshu Ranjan. Absent. Biplav Mahapatro. Absent. Fine. There were some students while I
Yes, sir.
went for the meeting, they did not respond. So I have seen that they left long back the class, and just after I started taking the attendance, they started joining. So I won't give them attendance. Okay, thank you. See you.
Hello, sir. Sir,
Bolo.
sir, did you ask my name?
What's your name?
Sir Mohsin.
Definitely.
Sir, I am
That is
present.
definitely.
I was,
No, you are not present at the time.
sir, I was in the whole class.
Then when I started asking for the roles, why didn't they respond?
Sir, maybe, sir, I didn't listen actually.
That means you are not present during that class time at that time.
Sir, I was in the whole class.
So if you are present in the whole during the whole class period, then how can you miss that?
Sorry, sir, I didn't know.
Okay, I am giving you benefit of doubt.
What, sir?
I am giving you benefit of doubt.
Okay, sir.
Okay, thank you. See you in the next class.
Thank you, sir.
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 Welcome.